In this video, we'll find out how much energy, that's heat, is required to melt a certain amount of some material. So to find the energy that's needed to melt copper, the first thing I need to realize is the energy, that's the amount of heat. So heat needed to melt copper, that's Q, and we have Q equals mL, and it's either LV or LF, depending on if it is vaporization or fusion. Melting, that's the transition from solid to liquid, so that's fusion. So Q is mLF. We're given a mass of 500 grams. I converted it here in my notes to half a kilogram. I also looked up the values for the latent heat of fusion and the latent heat of vaporization for copper. This can be found in a table from the textbook. Also, you can just look it up on Google. So in the textbook, these are given in a little bit strange units. This is 20.7 times 10 to the fourth joule per kilogram. I would have called this 2.07 times 10 to the fifth joules per kilogram. So just make sure you watch where the decimal place is in the book. All right, so we're looking at fusion. So this is 0.5 kilograms times 20.7 times 10 to the fourth joules per kilogram. So the kilograms cancel. We'll end up with joules, so that's good. So something joules, we have times 10 to the fourth here. I'm going to think of this as 2.07. I'm going to call it 10 to the fifth joules. And then I just need to divide this by 2. So this is 10.4 times 10 to the fifth joules. That's the amount of heat needed to melt copper. Now that assumes that the copper solid was already at the melting point. So if you had to take the solid and heat it up to the melting point, increasing the temperature, that would change our answer. In this one, we're just assuming that the only thing we have to do is melt it. We don't have to increase the temperature and then melt it.